I'd like you to open up your book to exercise 8-4. And we're going to build the equilateral triangle that Jasmine wants to work with. So using the regular polygon tool, I'm going to select 2 points, and I'm going to tell the tool that I would like a 3-sided figure with 3 congruent sides, and that gives me an equilateral triangle. She wants to use this to create a pinwheel. So how many will she need? Well, an equilateral triangle has angle measures of what? 180 divided by 3, 60 degrees each. So what's your prediction? How many reflections can I make before I have figure? That was an interesting reflection. I intended to reflect ABC over AC, but what I got was something very different. Now in this particular case, I am unable to reflect the reflection over the line. So I'm going to try to carefully put a point here. Well, yeah, if I put a point here at the intersection and create another polygon, I should be able to come close. Now, just like there were cutting errors today in class, I have a little error here at E. Do you see how point E is not exactly where it should be? So I'm going to need to prepare for a little bit of an error here. I'm going to reflect this over this, this over this, this over this point. Didn't work. Reflect over the point. Can I use a reflect through a point? Yes. So it takes 6 equilateral triangles to create the pinwheel that Jasmine wants, but really this isn't a pinwheel. What she's really created is a polygon. The name of this shape is a regular hexagon. Regular because why? Has 6 sides, each of equal measure. The term regular refers to the sides. All sides in any regular figure, are congruent. And that's really important. All sides in any regular figure are congruent. This regular hexagon has 6 sides, each of equal measure. All sides of any regular figure are congruent. Those are words I'd like you to pay attention to. Those are words you certainly will need to understand for the Unit 8 assessment. So let's make them larger, bolder, italicized, and let's change the color of them. You have a diagram on the page with 8-4 that shows you examples of non-convex polygons. One of those is a pinwheel type figure. That's the one that Inez made in example 8-1 with 120 degree central angles. And the others are simply non-convex polygons. Examples of convex polygons are on the right. If you connect any two consecutive vertices in a convex polygon, the connection segment lands on the side of the polygon. If you connect two consecutive sides in a non-convex polygon, sometimes you're creating a segment that is outside the figure. So find the methods and meanings box for convex and non-convex polygons and copy that definition down into the notes you're keeping for today. Not into the homework for tonight, but into the notes you're keeping for today. In 8.1.2, in exercise 8-14, and 8-13, you're asked to come up with methods for finding the interior angle sum of a polygon. So let's take a look at the figure. You have a pentagon. Now, it was suggested that you use what you know about the measure of all the interior angles of a triangle, and you know those equal 180. The reason that was suggested was because really you have nine angles that you could add together here in this figure. That have to equal the same as these three angle measures plus these three angle measures plus these three angle measures. So that equals the measure of the angles in triangle 1 plus the measure of the angles in triangle 2 plus the measure of the angles in triangle 3, which in turn equals 180 plus 180 plus 180. So the measure of angles 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 equals the interior angle sum for this pentagon, which equals 540 degrees. In tonight's homework, you're asked to open the lesson 8.1.2 resource page that's attached and use this same method. So in the four-sided figure, can I use the same method and say the angles of triangle 1 plus the angles of triangle 2 equal 360. Don't we know that to be true for a rectangle and also a square? So down here in the table for the four-sided figure, well, we know 360 degrees. Five-sided figure, we used a regular pentagon, but wouldn't it be true for this non-regular figure? This 180 plus this 180 plus this 180 equals 540. So for the three-sided figure, we used 1 times 180. We used one triangle to take the sum of the angle measures. For a four-sided figure, we used 2 triangles. For a 5-sided figure, how many triangles did we get? So that's going to continue to work for all of these non-regular figures. 1, 2, 3, 4. 6-sided figure, we're going to use 4 triangles. 4 times 180. 1. 7-sided figure, 1, 2, 3, 4, 5. So we need to kind of figure out what's happening here. 5 triangles. For an 8-sided figure, I'm able to draw 5 diagonals. How many triangles did I get? Nine-sided figure. I'm coming out with 8 triangles, but I know that that's not correct. So I'm going to draw more carefully. I have 1 triangle, 2, 3, and by now you're predicting how many I should get also. 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 triangles when I connect one vertex to all of the other possible diagonals. Now, isn't it true that I skip these 2 sides? If I draw diagonals to these 2 sides from this vertex, I'm not going to get anything. I just get the old lines that were already there. So that doesn't create a group of 180. So this is why I'm not getting 10 triangles. I should get 8 triangles when I connect all of those other vertices. Let's see if I do. One, 2, 3, 4, 5, 6, 7, 8 triangles, so 8 times 180. So please fill out the box for each of these figures. You can print this page, or you can copy the figures for this page. So you're going to have 2 assignments tonight. One is a performance assignment, that's a discussion board, and one is exercises. Do a good job on both. The performance points are important. And tomorrow is the Unit 7 test.